So let's talk about the Minkowski distance. So the first thing that we want to ask is why do we care? Why do we care about the Minkowski distance? Well, the motivation behind it is in data mining and machine learning. And machine learning, we often need to measure two things. Well, they're kind of the same, but similarity and or di- or dissimilarity. Dissimilarity. All right, between data points. Okay, so examples of this. Examples. Examples. Nearest neighbor search. Nearest neighbor search. Like finding similar customers, documents, or patterns. Clustering. Grouping by closeness, right? And outlier detection. Finding data far from the norm. So something we have to answer then for this is, what does closeness mean? What does closeness mean? So on a street grid, it means blocks walked. In open space, it means straight line distance. Okay. So we can go over the Minkowski distance formula here. So let's actually make that. Get rid of that. All right, so d of x, y is equal. Right, so distance r x y is equal to from k is equal to 1, the summation from k equals 1 to n of the absolute value of the x minus y k r to the 1 divided by r. Okay, and so to go back here, so we talk about the formula, or we can just say like general definition here. Let's actually get um, a new bring over some sticky notes here. Okay, so we can do general definition here. General definition of the Minkowski distance, right? Which we have that formula up there. All right, so general definition is a flexible formula that generalizes um, Okay, a flexible formula that generalizes many common distances. All right. So, and then this formula is for 2 points, for 2 points, right? X is x1, x2, xn, y is y, y1, y2 to yn. R is the parameter. R is, well, it's just ultimately capitalizing it. So R is the parameter that changes the flavor of the distance, changes the flavor of the distance. Okay, larger R gives more weight to larger coordinate differences. All right. We get another sticky note here. All right. Um, all right. And let's just go over the applications of this, and then we can go over an example. Applications. Manhattan distance for text mining recommenders. Euclidean. And ultimately, this is about solving whether or not your model gives you a meaningful output. Just because it can do the math doesn't mean that it's meaningful. And so this can help us with similarity of our data. And so we can have a more impactful result in our model. So we have Euclidean distance, geometry, clustering, and nearest neighbors. All right, and Chebyshev, I think that's how you say that, Chebyshev distance, games like chess. So these are just some applications of it. And Minkowski for general, all right, for ML algorithms. All right, and that's where I want to stop. So see you next.